For our first problem today, let's go over change of base. I feel like it's a really important concept because I don't think we really practice it enough necessarily. And it can be really, really helpful. It does practice your knowledge of algebra. We have a fraction here with exponents on top and bottom. We cannot combine these exponents. Typically, we're supposed to subtract these exponents and to simplify this fraction. However, we can't because we don't have a matching base on top and bottom. We have a 3 on top and a 9 on bottom. However, we can use change of base to help us out. 9 can be rewritten as 3 squared. Now, we all know this, and it feels like we're working backwards. However, once we plug that in, you can see how it can become very helpful. The only difference is we have power to power. On the denominator, we have 3 squared to the third power now. 3 squared to the third power means we just multiply those exponents. We get 3 to the fourth up top. Down below, we have 3 to the sixth. Again, we multiply the exponents when we see power to power or exponent to exponent. At this last step, we do have matching base. We do have a matching base. We could subtract those exponents. I know that my result is going to be down below because the larger exponent is also down below in the denominator. The 4 is smaller than the 6, so I put 3 to the second power down below. And again, I get this second power, I get that 2, from finding the difference between 4 and 6. So my final answer is 1/9. All right, we're off to a great start. Let's do another problem here. We have x to the negative second power times y over, let's do over 5, times x to the third times 3 over y to the third. All right, so notice that we don't have any separate terms. We don't have any plus or minus signs throughout any of these fractions or in between the fractions. This is great news. No plus or minus signs. This means we just multiply straight across top and bottom. So let's do the denominator first. That one is simpler. We have 5 times y to the third power. That is just 5y to the third power, nothing crazy. Up top, it's a little bit different. Be careful with the exponents here. We just want to focus on what has a matching base. We have the x's that do match each other. When we multiply, we add exponents. When we multiply with a matching base, we add exponents. So that gives us x to the first power. And when you have something to the first power, you don't write the 1. So we just have x. On the other hand, we have a y and a 3. These guys don't disappear. You can write these 3 numbers and letters in any order. So 3xy, for example, over 5y to the third. Both of these are correct notations. I have a habit of putting the number up front, though. So one more step, we have to cancel out or cross out any letters that match top and bottom. We do have a y on top and a y on bottom. As you know, we subtract those exponents, and that's an invisible 1 up top, by the way. So we have 3x over 5y squared. And it may look like there's more to do, but there's not much else we could do about that. So that's our final answer. When you practice these rules, you get the confidence of knowing when to stop and when there are rules that you can utilize or when you need to stop before you break any rules. Let's do another one. We have 3 times x plus 1 to the negative first power, all divided by 4x plus 2. Now, I love this problem because that negative 1 exponent, a lot of students make the mistake of applying it not just to this group in parentheses, but also to the 3. Guys, that negative 1 exponent does not go to the 3. It does not apply to the 3. The parentheses are what tell you that. It only applies to the parentheses. So what this looks like with our next step is we keep the 3 up top all by itself. Down below, we have x plus 1 to the positive 1 power now, times 4x plus 2. Understand that I'm going to put parentheses over the 4x plus 2 because this group that I bracketed, when it moves to the bottom, it doesn't just multiply with the 4x. It multiplies with the entire group 4x plus 2. And that's why I put the parentheses. So be responsible about your parentheses, guys. It changes the question drastically. We are going to FOIL this. So we have 3 on top, and then we have x times 4x. That's 4x squared. X times a positive 2, so that's plus 2x. Positive 1 plus the positive 1 times 4x, giving us a plus 4x. And then a positive 1 times the 2, giving us a plus 2. Let me see, that's all in screen. Oh, I think that's all in screen. I hope that's all on screen. So I'll rewrite this down below anyways. We have 3 over 4x squared plus 2x plus 4x plus 2. The last step, guys, is to combine like terms. The 2x and 4x are the only like terms we have, so our final answer is 3 over 4x squared plus 6x plus 2. Sorry, that's supposed to be the fraction bar. Okay. All right, so we are looking good. However, you might see an alternative version of this final answer, and that is to take out the GCF from the denominator. There is a GCF in the denominator, and the GCF is 2. We could pull out a 2 from each of those terms down below, leaving us with 3 over 2 times 2x squared plus 3x plus 1. Now, if you're uncertain about how I did this and you're uncomfortable about pulling out a GCF, I do have videos on GCF, greatest common factor, and how to factor it out. Okay, so each of these answers are a proper final answer. Again, it's pretty magnificent what we could do by hand. Let's keep going. We got, we're going to move on to a slightly different topic here. We're going to rewrite a fractional exponent. I'll just put the word fractional. That's what's going to stick out here. What I want to do is I want to compare two different situations. They look very similar, but you'll see that they lead to very, very different answers. That's x to the 3/4 versus x to the negative 3/4. So for x to the 3/4, you would be familiar with this if you did see the video I have covering exponents. We're basically going to turn this into a radical, putting the x on the inside. Now the denominator of a fraction that is in the exponent always has to go in the index, or as I like to call the pocket. Now the numerator, 3, is going to go on the inside of the radical. In this case, the bigger number is what's in the index because the bigger number is the denominator, but that is not always true. Sometimes the bigger number is the numerator. Just follow the rules that the denominator goes in the index. All right, so at this point in time, we can't really simplify this any further. That would be our final answer. And that's where this gets very different from the other side here. We have what is going to become 1 over x to the 3/4 power. We have a negative fractional exponent. Just try to knock things out one at a time. We know that a negative sign in the exponent flips the sign, or flips the side that our term is in, all right, of a fraction. Now let's convert that into a radical, like we just did over on the left-hand side. We have the 4th root of x to the 3rd. Now, you're not allowed to keep a radical down below in the denominator of a fraction. So what you have to do is multiply top and bottom this radical. Let me show you what that looks like here. In blue ink, you'll see I'm going to multiply by the 4th root of x to the 3rd, top and bottom. What we're doing is we're multiplying by the number 1, and that's why we are allowed to do this. But you might wonder why. Why are we doing this? Because a radical cannot be in the denominator. It causes complications with the domain of the function. That's a different lesson though. But let's continue. In the denominator, the root is going to cancel. So we are essentially going to have in the denominator x to the 3rd power. In the numerator, we're going to have the 4th root of x to the 3rd power. And that's your final answer. Now, with that, you have a green light. There's no domain issues in this problem because there's no radical down below. All right, we're looking good so far. 2 more questions to go. Any requests, leave down in the comments. I'll be happy to do a follow-up video for anybody requesting any specific math topics. All right, let's see. We have x to the 4th, y to the negative 6th, all to the 1/2 power, times, let's see, x to the 3rd, y to the 5th. If I were you, I would take care of this fractional exponent first. And let me show you a trick. Instead of putting this group into a radical, what you can do is you can apply the power-to-power theory to a fractional exponent, meaning I can rewrite this first group as x to the 4 times 1/2 power and y to the negative 6 times 1/2 power. Now at this point, we could finish up the multiplication within each of these exponents. So we have x to the 2nd power, y to the negative 3rd power, times x to the 3rd, y to the 5th. when we're multiplying these groups, don't be overwhelmed by these parentheses. We're only going to combine the like terms anyways. So this x to the second power is going to combine with x to the third power, giving us x to the fifth in our final answer. The y's are also going to combine, giving us y to the negative 15th. Not y to the 15th, y to the positive second. Sorry about that. So we have x to the fifth, y to the second. There's nothing else we could do. That is our final answer. There are many ways you could have gone about this, including rewriting y to the negative third down below in the denominator. But I feel like this is a more streamlined way to do it. We're following all the rules, keeping things simple, reducing the amount of decisions that we make. So here we go. On to the last question. We have 4 times x plus 2 to the third power over parentheses 2x plus 4 times x plus 2. Okay, so some things to go over. This exponent of 3 does not apply to the 4, and the 2x plus 4, x plus 2 should not be FOILed. You should not start multiplying these things out. That would be a waste of time, and the reason why is because there is something quite peculiar about this fraction. While we do have some plus signs scattered throughout the fraction, we don't have any plus signs between the large groups involved. And so what that really tells us is, since there's no plus or minus signs in between the different groups on the top and bottom, there should be a way that we could simplify by crossing out the entire group. So hopefully you can notice that there's an x plus 2 up top and an x plus 2 down below. That is very helpful, and we want to maintain that. However, there's another step you could take to reveal another group that we can cancel. Looking at this first group in the denominator, the 2x plus 4, we can factor out a 2 from that group itself. Here's my numerator, and this is what I mean. We have a 2 times x plus 2. That's this first group that I have the blue parentheses over, rewritten with the GCF pulled out. Then don't forget the other x plus 2. Now we have 4x plus 2 to the third power over 2x plus 2 to the second power. Notice that I have a matching group here being multiplied together. If you want, you could rewrite that as the same group to the second power, because we know that's what we're saying basically, x plus 2 squared. Now we could easily see that the 4 and 2, the numbers out front, can cancel each other out. We have a 2 up top and technically a 1 down below, but we don't draw the 1 because we're multiplying it. And then for the groups, we have the x plus 2 to the third power, x plus 2 to the second power, leaving us with nothing but an x plus 2 to the first power up top. And there's our 1 that I mentioned. We could rewrite this only one more time to get our final answer, 2 parentheses x plus 2. Or, of course, 2x plus 4. That's if we distribute out the 2. Very difficult problem because it baits you into your tendency to do the FOIL method up front as your first step. That would be catastrophic as a first step. You'd be essentially kind of stuck with how to correctly simplify this. However, if you notice that you could pull the GCF out, then you'll see that the groups are less intimidating than what they really look like. And yes, we're treating the group x plus 2 as if it were just one letter or one number, like y to the third over y to the second. And you are allowed to do that. The parentheses allow you to do that. All right, so let me double check. Yes, that wraps up all of our questions today, guys. Again, leave any comments. Feel free to subscribe. I'll leave links in the description to previous videos relating to this topic. And thank you for watching. Thank you for the support. I really appreciate it. Thank you.